Okay, I'm going to go ahead and give you the answers for the chapter review and go along. So if you got the correct answer or you didn't know how to get the correct answer, you can listen to my explanation on this. Otherwise, if you did fine, or I'm going to start at question 1. If you think you want to get the answer to question 9, you can fast forward or jump around and try to figure out where that is. Okay, write the ratio in simplest form. So if I give you the ratio in this form, right, you can still reduce. Look at 15, look at 25. Either put it into your calculator and do math frac, or you just see they're both divisible by 5, right? So I'm going to get a simplified ratio of 3 to 5. If there's 3 of them, it's not any trickier. We just have to divide each one by the same number. So notice they are all divisible by 3. So my new ratio is 2 to 4 to 3. For question number 3, we are going to cancel. So we have 16xy and we have 24x squared. Well, x squared, remember, means x times x. So what can we do? We can cancel 1x for 1x. They both become the number 1. And 16 and 24 are both divisible by 4, so I'm going to divide 16 by 4 to get 4, divide 24 by 4 to get 6. Oh, well, they're actually both divisible by 8. So I'm going to divide 4 by 2 to get 2, and 6 by 2 to get 6. 6 divided by 2 is 3, so there you have it. So we get, for our final answer, 2 times 1 times y, which is 2y, and 3 times 1 times x, which is 3x. Okay, look at number 4. It says the measures of the angles of a triangle are in the ratio of 4 to 4 to 7. Find the 3 measures. Well, right here, if they're the angles of the triangle, we know the measures of one angle plus the second angle plus the third angle must equal 180 degrees. Remember, this is the scale factor. So we need to figure out which common number they're being multiplied by in order to get it to 180 degrees. So 8 plus 7 is 15, so we do 15x equals 180, divide each side by 15, so x equals 12. So find the measures of the angles. Well, this is not the answer to the measures of the angles. We have to go back and plug it in here. So what do? We do 4 times 12, which one of the angles is 48 degrees. Well, this is the same angle, which is 48 degrees. And then 12 times 7, what's that going to give us? 84 degrees. And then you can make sure 96 plus 84, that adds to 180. So I know it is correct. So those are my 3 measures, 48, 48, and 84. Number 5 through 8, it says, is the equation equivalent to the given proportion? So here's my given proportion. Remember, if I'm going to check this, I'm just going to check their cross products, or their the product of the extremes and the product of the means. So this is 7 times 30 minus x, right, if I multiply this way, and this is 8 times x. So the product of the extremes equals the product of the means. So now I need to test that with everything over here. Well, right here I can see 7x number 5 equals 8 times 30 minus x. That's definitely not equivalent. Let's try number 6. Number 6, they're giving it to me in proportion form, so let's check the value of the product. So I do 8 times x, which is 8x, and I do 30 minus x times 7. So that's 30 minus x times 7. So is it the same? Yes, it is. So 6 works. Let's look at number 7. If I took this answer right here, notice they have a 210, so that says something. That says I need to distribute the 7. So 7 times 30 is 210, and 7 times negative x is negative 7x. So now does my purple, because this is equivalent, all 3 of these statements are equivalent equations. So are these 2 equivalent? Yes, they are. 210 minus 7x equals 8x. 210 minus 7x equals 8x. So yes, 7 works. Okay, let's check number 8. 8, we need to find the cross product. So 7 times 30 is 210, and 8 times 15 is 15x. X times 15 is 15x. Okay, well, one more thing we need to do, let's take this equation and manipulate it by adding 7x to both sides. So when I add 7x to both sides, I bring down my 210. 8x plus 7x is 15x. So are these two statements equivalent? Yes, they are. So 8 also works. So the only one that does not work is number 5. But notice the algebra I had to do to reinforce the fact that these were equivalent proportions. So they're all equivalent because they're all reducing to the same thing. Okay, number 9. It says if triangle ABC, remember this symbol is similar, if triangle ABC is similar to NJT, then angle B is congruent to what? Well, just like congruency and similarity, the order of the letters matters. It tells you which angle is congruent to which angle, and it also tells you which sides are proportional to each other. So angle A is congruent to angle N, angle B is congruent to angle J, angle C is congruent to angle T. AB is to NJ as side length AC is to NT as BC is to JT. So the order of the letters is very important. Okay, number 10. If quadrilateral DEFG is similar to quadrilateral PQRS, okay, this is what I just said, the order of the letters matters. So if they said then FG is to RS as, then go to this one, it says as DG is to, well, it's first place and last place, so we have to go first place, last place, so this is going to be PS. Okay, number 11. If triangle ABC is similar to triangle JET, and the scale factor of ABC to JET is 5 to 3. So my understanding of scale factor, it means that this is the bigger triangle, right? It's a 5 to 3 relationship. So if BC equals 20, find ET. So we say BC is to ET as 5 is to 3. So BC is 20, so 20 is to the measure of AT as 5 is to 3. I cross multiply, I get 60 equals 5 times ET. I divide by 5. So the length of ET equals 12. So this answer you should have gotten is 12. If the perimeter of triangle JET is 30, then what is the perimeter of triangle ABC? Okay, well, do we have to know all 3 side lengths? No, because they still have this dimensional relationship, because perimeter is just the side lengths, the sum of the side lengths added together. So we would say 5 is to 3, as we don't know the perimeter of ABC, but we do know the perimeter of JET. Right? So 5 is to 3 as x is to 30. So we cross multiply 5 times 30. I'm going to keep my 3 over here, right? Because there's no sense in putting it back over to the x, only to divide it again. So x equals 50. So the perimeter of ABC is equal to 50. Remember in the beginning we said triangle ABC is bigger than triangle JET, right? This is ABC in the numerator, this is JET in the denominator. So my answers for ABC should always be bigger than my values for JET. So you can go back and kind of do that check. ABC is bigger than JET, so that worked. ABC is bigger than JET, so that's also further just kind of gives you a little clue that yes, you're probably on the right track. Okay, number 12. The quadrilaterals are similar. Find the values of x and y. So we're looking at this picture right here. So we need to first identify what's the order that we're going to go in. So if this is a 90-degree angle, this is a 90-degree angle. So because these are supplementary, and this angle they share are the same measure. So it looks like if we go around this quadrilateral counterclockwise, but we go around this one clockwise, right, then we'll see which sides line up with each other. So y lines up to 9, so y is to 9 as 12 is to 8, as x is to 6. So I can solve for this. Y is to 9 as 12 is to 8. This is my scale factor here, 12/8, which I could reduce if I wanted to make it a little easier for myself. Reduce that by 4, so I'd get 3/2. So I cross multiply here, y equals 27. I'm going to keep the 2 over here because there's no point in moving it back. So y equals 13.5, right? 2 times y equals 27 divided by 2, so we get 13.5. Or we multiply here, we say 2x equals 18 divided by 2, so x equals 9. Or you could have just multiplied this by 6 and then divided by 2 to get 9. So to me it looks like y should be 13.5 and x should be 9. Alright, let's look at the next one. I'm going to erase this stuff right here to make some more room for number 13. Okay, it says 13a, triangle RTS is similar to what? What postulate or theorem justifies the statement in part A? Okay, well here is angle N, and this triangle also has an angle N. This triangle RTS has angle J, so I'm going to mark it with 2 marks. This triangle also has an angle J. So why are these two triangles similar to each other? Because of the angle-angle postulate. If I go from R to T to S, so I went from double mark to single mark, or from angle J degrees to N degrees to no degrees, I need to go from J degrees to N degrees to no degrees. So I have to go U, V, H. So this answer here is triangle UVH. And why? Because they both have a J degree angle and an N degree angle. So let's set up the proportion. Well, again, the order matters a lot. So RT is to UV, because those are the first two, as TS is to VH, as RS, so this is first and last, is to first and last, UH. Suppose you wanted to prove that RS times UV equals RT times UH. You would first use similar triangles to show that RS, right, so we can use this one, RS is to UH as RT is to UV. And then what do? We cross multiply. Or you can multiply each side by UV, multiply each side by UV, cancel, so RS times UV divided by UH equals RT. Then we multiply each side by UH, multiply each side by UH, these cancel, and then we have this statement, RS times UV equals RT times UH. So that's how you would solve it algebraically. And finally, the last few problems, I might need another video to finish it, but we'll try and do as much as we can in this minute and a half. It says, can the two triangles be proved similar? So we're looking at these two triangles over here. If so, state the similarity and postulate or theorem you would use. If not, write no. So if you were given that angle A is congruent to angle D, could we then determine that these two triangles were similar? Well, actually, yes, we could, because these are vertical angles right here. Based on the vertical angle theorem, angle ANB is congruent to angle CND, because those are vertical angles. And then because of AA, we would then know that triangle ANB, so let's do the order there. Triangle ANB is similar to what? So from singular mark to double mark. So I have to go from singular mark to double mark to no mark. So that is triangle DNC. Okay, then I have to erase and start over. Okay, let's see if we can fit in one more. If angle B is congruent to angle D, well, once again, you could still say that those were similar to each other because of the angle. So yes, once again, because of angle. But this time, what would the order of the letters be? Would it be the same? Find out on the next video. Dun, dun.